In this video, I will demonstrate the main features of the QRM Quality Result Management web application. The first thing you see is the login page, and I just put in the username and the password. Yes. Keep me logged in. The first thing you see is the overview tab here, and it shows to the left the total number of units tested today, last 7 days, last 30 days, and last 12 months. To the right, we can see the corresponding yield for today, last 7 days, last 30 days, last 12 months. In this example, I actually have 3 different UT types, UT, unit under test. So I have one model called Q823, and this one, and this one. So if I want some more details about this one, perhaps I just specify this one, and I get some more details. Here I can see the last 24 hours production, last 30 days. If I just click any graph in QRM web application, it will actually zoom in, giving me more details. Like this, click again, zoom out, and here's the yield. Click in. Yeah, quite nice. Click out. And I go back like this. I can also select if I'm interested in one certain station. I can select one station. This background information is updated every 15 minutes, and it gives you a good overview of what's happening in production. The next tab is the test results tab up here. If I click this, you will actually see much larger filter. This is one of the most important things in the QRM web application, is to set the filter correctly. And you have the UT type, the start date, and the stop date. Those 3 are really important because you will be working a lot with those. So if I just press execute, I will see the last, it's by default 1 week back. I will see the last day's production. I can expand here. And here we can see this is an execution with 18 units, 288 and 32 units. I can group them by week, like this, or by month. Or I can also group them by UT type instead, like this, and then I get the individual serial numbers. Depends on what you want to do actually. So, but if I go back to the result sets per day, like this, if I click here, we can see that here are all my 32 units that has been executed. I can see here that the starting at 1:30, ended at 2 o'clock, and here are the different serial numbers, the UT type, and here are the start-stop time for this individual. And here I can see which test sockets been using. So this is actually PCBA testing with 8 test sockets. So if I click here, I get the details in the testing. And in QRM, tests are grouped in something called result groups. So this is a result groups called NXP gang programming. It actually just have one result. This is another programming, and here we have the main functionality group, has a lot of measurements, and here are some more with some more measurements. So we can actually see the result name, the measurement value, the unit, and the requirements, like this, for each measurement. We can also filter out just the fail units like this, if you want. Yeah, just one. But if I go back like this, we can very easy also go select these 3, get a PDF report, open in Acrobat, and then we have the test report like this for these 3 units. I can also just select all, download the CSV, open up in Excel, and get all the measurement values directly to Excel. Very, very simple to export data out of QRM. The next tab is the production report tab. If I click this one here, I get some more details regarding the production. So if I just press execute, I will just have the details of the production for the last 7 days. It's quite similar to the overview tab, but the production report will calculate directly, because the overview tab will actually calculate in the background as results get in, but the production report will make a new calculation and also make sure there are no duplicate units and so on when calculating yield. And I also can get some more information here if I just select, like here. I can also divide into variants. I just have one variance now. I can get a list of the failed results like this. If I go down here we have the top 25 most common failed results like this. I can download the production report to PDF, of course. Really nice to show you managers and the quality departments. I can get a list of all the serial numbers of the UTs that has been tested during this time period. Like this. Excel hides. Like this. The next tab is the yield tab. If I click here, this tab will actually break down the yield. Let's say you have a yield of 99%, but you want to know which test is actually causing this low yield. Then you need to analyze and see what are the yields of the individual tests causing this bad yield. So if I let's try to analyze this one for the last week. Just press execute, and here we can see that we have 6 different result groups, and here's the number of units tested. Here is the corresponding yield for each result group. These are sorted with the lowest yield first, and we can see that we have the external input with the yield of only 98.93%. So let's try to dig into that one. And here are the yield by time, so we have to select one of these, and it's already selected the one with the lowest yield. So here is number of units produced for each day. Here is the yield for the same day. It's quite high actually, so just click again. And you can also group them by week, by month. You can also have a threshold of how many UTs should there be for this time interval to calculate yield. And if we would like to dig into this external input single com test, see what are the actual measurements we perform, then we can see that we do 6 different measurements here, where the external input amplifier right has the lowest yield. And we can see the details of this yield for this measurement here. So now we have identified the root cause of which is the measurement that has the lowest yield. The next tab would be the SPC analysis, statistical process control. So now I would like to see the actual measurement values for this one, external input right. So if I go up here, press the SPC tab, you can see that the filter has already been pre-selected with this external input right for the same date. So if I just press execute, we can see that we get the individual measurement values here, and we can directly see with our eyes that there are 1, 2, 3, 4, 5 dead units that is probably causing the low yield. So I don't want to look at these dead units, so I just remove outliers, press that button there, and we will have all the outliers removed. And to the right we can see a nice histogram. Click to zoom, and we can see that it's really nice bell shape, and it appears to be normal distributed, which is really good. That's a good indicator of a good measurement. But we can see that this is the limits, the upper specification limit here and the lower specification limits here, and we can see that our measurements are not really centered. So the mean value should be here instead of here. Yeah. And we can also see that we have some strange things here, and that can be because we have a couple of executions here. Yeah, we have an MSA running that's included here, where we tested units over and over again, so we can actually say test type to be just PCBA, not an MSA run. So if I do it again, yeah, we can see we still have the dead use remove outliers. Yeah, now that's gone. That was something from the MSA run. And here is the normal probability plot. Here are the CPK values down here. If I scroll down, yeah, you have the mean value with confidence intervals, number of samples, and so on. We can see here that we have some analysis of the process summaries. We can see that we have a quite large number of data points. It passes the goodness of fit for normal distributed, so it's a really nice data set we have here. We have just some warnings about patterns. It's up here, the red ones. We can click and zoom, but the data looks really nice anyway. And if I go down here, we can see the capability of the process is really good. We actually reached 6 sigma level 6 because we have a CPK of 3.78. That's really good. It could be as high as 6.3 if we had the limit center would be the same as the process mean, like this. If the center here would be here, CPK would be over 6. And down here we can actually see a backward calculation. If I would like exactly CPK of 1.33, then my limit should be 1.038 and 1.1122. Really nice way of trim your process when you don't really know the limits. Yes, the next tab is the MSA tab, the measurement system analysis. And if I go back like this, and in my example here I have actually marked the test that has been used for an MSA. An MSA is where you try to analyze how good your measurement system are and if the variations is from your test system or is from your unit under test. So if we have a look, first we can go to the test results, actually look at this MSA run. Yeah, we have one here, 160 units like this, and you can see that here we have the serial numbers. We run them over and over again a couple of times, over and over again. Then we take the next unit and run them over and over again. I think I run them 5 times each here. So if I go to MSA now, go back here, use the all, and press again. Now we will get a really nice calculation of all the measurement values here. We can see that I have 32 individuals. I've tested them 5 times each. I have 8 appraisers that would be test sockets in this example. And we can see here is the we have the precision to tolerance, we have the contribution to the variance of the gauge. So if I click this here, you have the traditional gauge R&R analysis. So in just one click I get a gauge R&R analysis of the entire system. That will be very, very time consuming to do for in another system, like for a mini tab like this. And I can also get a really, really nice PDF report with all the details of all my measurements here. Like this. Here's an MSA report, and I get all the different measurements here. With the range charts, X-bar charts, the contributions, the ANOVA calculations, and so on. The next tab is the Stations tab. If I click here, I will just get some statistics of how the stations are utilized. We have here in percentage of workdays hours, how much time they are used. These stations are probably not used at all. This one has only 11% usage. Very good potential of increasing testing. Here are the different UT types we have tested, and it's based on time, how much time they occupy. So in this BPC we can see that mostly 8 to 3s are tested and just some 4 3-2s. We can also see how many units has been tested during the time, and we can also see what is the average number of UTs executed each time you press the run button. And here we can see what is the average test time for each UTs, and if we, for instance, do some parallel testing, this parallel testing will actually be considered as well, so you get the true test time here. Here's the average sequence execution time. That's so for how many minutes are the machine running without someone doing anything. So it's for this one here, it's really, really low, just 2 minutes in the sequence. That's a really short sequence. Here is number of sequences executed by hour. When do they start the sequences? We can see that they are started in the morning. Here is which day of week are they started. We can see that they are started on all days but Fridays and Saturdays. So why is the machine not working on Fridays, perhaps? You can see here. And you can of course get a PDF report as well here. You can also get some details about this station here. You can see more details. The next tab is the Repairs tab. If I press this one here, we can actually get some repairs data that has been performed on the UTs. And we can see here, if I just click here, no repairs found. So we don't have any repairs for the interval, so just let's add. So if I do like this, and we try to find a failed unit here. No, we don't want MSA, so we just do it again. And we have a failed unit here. Okay, so it's ending in 448 as the serial number. So let's go back. 448. Execute. Yeah, here is the 448, and it's not repaired. We can actually just click here, and then we actually see the last test report for this one. We can see that it has some problems with the external input here, and we can go back here. So let's add a new report. Let's say this action is called B1. We do a repair, and we can say we have a bad soldering on R14 on that protein, the new one like this, NU, and this report will be added here. Now we have a new repairs, and if I remove this one, click Next. We have, you can see that's still here, and if we go back here, we can put the 448 back and find our unit again. Like this. Yes, here it is. And now we can click this as well, press execute again. Now you will actually see that we can have attached a repair to this one. Here it is. The next tab is the Export tab. The Export tab is where you export results to CSV file. So if I first remove that filter here and remove the serial number filter like that, we go to the Export tab. And here you see all the measurement values. And let's say I just want to export the reverse current and the mic out power like this, and then I can just press download CSV directly to Excel like this. I just get the serial number, the measurement values that I requested. You can export data from the test results as I showed you, and also from the SPC analysis, but the export you can just select I want that one and just export. Really simple way just exporting.